Hello my friend, today we're going to do another recursion exercise. The idea is to make a lot of practice, so all this recursion deal is going to become an ice cream vanilla. Today we have to create the putNumber function, right? A function that is able to print in the standard output the integer gave as an input. Of course, the function has to be able to display all the possible values within an integer, right? From integer min to integer max. And here we have the prototype. So a function that takes an integer and doesn't return anything because the only thing that has to perform is to print. So as usual, I'm going in our terminal and I do vim putNumber.c. We can only use the write system call, so we have to include our UniSTD, Unix standard, and then of course the main function, so int main. Now here inside the main, I'm going to write all the test cases that we will perform in our function putNumber. All right, here as you can see, I have all my tests with the function putNumber and all the inputs, right, which are integers. Here, of course, I have symbolic constants coming from the limits.h file, so I'm going to include that, include limits.h. Of course, I can also hard type this number, but it's going to be super tedious, right? I have to write 2,147,48,36,47, right? And the same thing for int min, which is just the same number with one more, and of course this is negative. Then I just have a new line for having a better output, and then I have all the other tests with a 0, with this number, and with this other number. Cool. Let's implement the putNumber function. I'm gonna just write a prototype because I want the main at the top. So I'm gonna do void putNumber, and as an input I have an integer. Okay, perfect. Now we're gonna define the function putNumber. So again, void putNumber int n. And first of all, I'm gonna do with iteration, so we can appreciate the differences between iteration and recursion for this specific case, for this specific problem. Okay, I'll zoom a little bit and I center the image, ZZ, and I start to type. I won't get too much into details. I hope you know what is an integer, the choose complements idea, right? And what is an int max, int min, why we have an int min, which is one more than int max, and so forth. All these ideas. This video is meant to be highly practical. So let's deconstruct the problem with iteration. We have a number, right? We have n, which can be this one. What I want to do is that I want to take every figure, every digit that is composing the number, and then just write in the standard output using the write function. How can I achieve that goal? Well, given that this is a number, I can use the operators, right? I can use the division. If I do 1337 divided by 10, I get 133. Basically, I cat the last figure. Okay, when I do the modulo, what do I get? Well, I get the last figure. I have 7. So I will use these two operators to cat the number and take the last digit that I want to write. You see? Now, what is the problem here? Well, the thing is that the first digit that I want to write is this 1 here, right? It's not the 7 at the bottom, because I can do modulo initially. I take the 7 and then I just cut this 7 and then I remain with this value. Then I can perform the same operation, right? I can do this, so I get the figure 3, and then as before I will do the division, so I remain with 13, and I go on. You understand, right? The algorithm. I take the last figure and then I just cut that, so I will keep going on until I have only one figure. Now, given that I want to print, first of all, this 1, I have to engineer this algorithm in a specific fashion, and now I will show you. So for that, I can exploit an array. I will stock all these figures, you see, from here, inside an array, and then I will print all the figures in reverse. Let's do like that. I will have char array with how many elements? Well, the biggest value I can have for an integer is this one, which has exactly 10 figures. So you are just gonna have an array of 10 elements. That's totally enough. Of course, of chars, because we are gonna need chars, not integers. Then I just need an index, an iterator. So I'm gonna do int I. And then we start, of course, I is gonna be 0, index in position 0. Then what do? Well, first of all, I check if the number is equal to 0. So I do if 0 is equal to n. What do? Well, you just have to write the number and then just return. You have finished. So what do? Write in the standard output, so 1. Here I can use a string literal because we know that the write wants a pointer, and then of course only 1 byte. Now I can more elegantly use a putchar that I create with the write function, so maybe the code is gonna become more readable. So we're gonna do that very fast. I'm gonna do void my putchar char c, and I use the write function right inside. So write 1, the address of c 1. Okay, so I have this my putchar that is wrapping this system call, which is more cryptic to read, right? So here I say my putchar char c is gonna be the char 0. Okay, and then of course I'm gonna return nothing because we have a void as a return value. Cool. So this is the case by which the value is equal to 0. Then another case can be if the number is negative, right? So if n is minor than 0. What do we do in this case? Well, in this case I need to invert this boy, right? Because I don't want to perform all these operations with a negative value. So I want to deal only with positives. How can I do that? Well, here I can simply say n is equal to minus n. This is going to invert the value. Choose complement way, you can do n is equal to tilde n plus 1. This will do exactly the same, and we're going to do that just for fun because we have a choose complement machine and we represent negative numbers as the complement plus 1. Basically, if you watch the binary, we have all the bits which are just the inverse plus 1. So we say choose complement way. But is this okay? What do you think? Well, if we have here the number, this one, which is int min, what is going to happen if I invert it? I cannot have this value here, right? I cannot have an integer with this representation because int max is this. So in the case I have this number, what can I do? Well, I can say if n is equal to int min, you just write it and you exit. So you do a write, we're going to use directly that, and you write the number, so minus and this big boy here. And then here you have 11 chars, right? So 11. And then of course you just return and we're finished. On the contrary, you just invert the value. So now you have a positive 1. And then of course we are not finished because we have to write the negative sign, right? So we're gonna do my putchar negative, okay? Here we are. So immediately you flash out this sign. Okay, so I have the case by which the number is equal to 0 when it's minor than 0. Now we get into the real deal. As we said before, I want to stock inside my array all these digits. Let me finish to represent visually what is going on. So we have this scenario here, right? I have this number. Every time I'm gonna take the last figure with the modulo operator, and then I'm gonna divide. I'm gonna cut this. Then I'm gonna do the same. So every time I get the specific figure. At the bottom, I will have the first one, if you want the most significant figure, 1337. And at the end, I have 0, right? So I'm gonna create a loop accordingly. I'm gonna say while n is major than 0, okay? I want you to stock in my array in position I the figure, so n modulo 10, but I don't want the number, right? I don't want the number itself, the integer. I don't want the 7 integer, I want the 7 char. And of course, to swap, to change between, to toggle between an integer and a char, I just do plus 48, or I can do plus 0. It's exactly the same. So I get 7 here, right? Plus 48, I get 55. And of course, 55 is the char 7, is the symbol 7, is not anymore the integer. Cool. And of course, I'm gonna just divide by 10. So nb divided equal 10. Right? So we're gonna perform exactly the algorithm you just saw here, right? We're gonna do that. Of course, I have to increase I. I can do it directly with a postfix increment. So I'm gonna do I++. So every time we have the index that is gonna move. Here, of course, I have n and not nb. Nice. Then at the end, I have just to write all the symbols which are stocked inside my array. So what do? I just say while while what in this case? While I is major and equal to 0, because we need to use the index position 0. What do? We just put char, so my put char of array in position I with a prefix decrement, because I with the postfix here is just one position more than the last value. And here we are, I think, right? I think the algorithm is ready to rumble. Let's try to launch it and let's see if it works. So I'm going to compile, put number and launch. So I have int max, int min, 0, 402 and minus 42, which were exactly my cases, right? Int max, int min, 0, 402 and minus 42. So it seems that the code is working properly. Now let's just very fast visualize what is going on with ctutor. It's always a good idea to see this kind of programs. In the first case, we get int max here, and then let's see what is going on. So as you can see, we start, we do our checks if it's negative or it is 0, and here we have the actual algorithm. While n is major than 0, we start our algorithm of taking the last figure and stocking inside the array. So you will see the array with all the figures in reverse. You see, every time I take the last one and I put inside my array. Of course, the array is filled because that was the biggest number. At the end, I have n divided equal 10, so I get 0. So the loop is gonna end. And you see exactly the number in reverse here. 2,147, 48, 36, 37. Cool. So you understand very well the algorithm. The only thing maybe is that why we have this minus minus I here and not I minus minus. Well, because I have I which is equal to 10 at this position because of this postfix increment of the previous loop. Anyway, that's it for the iteration algorithm. Now we're gonna do with recursion that, in my opinion, is much more elegant than this approach. Okay, so we're gonna do the same. Gonna comment all of this. And now we're gonna do recursion. So void number int n. So every time we do recursion, we have to think about the case bases, namely the conditions by which this recursion, this repetition is gonna end. Which are these conditions in my case? Well, of course, the condition is when the number is one figure, right? It's only one figure. So I can say if the number is minor than 10. Well, that's the condition by which you have to write in the standard output the value. So you do my put char and plus 48. So here I have one figure. I write that. What is on the contrary the recursiveness, the repetition that is going on? Well, all the division and modulo operations, right? All these other cases will be handled recursively. We are gonna perform many functions to handle all of them. So I'm gonna say else. So this is the recursion. So here in this else, what do we have? Well, in this else, we have all the other cases by which we don't have only one figure. For example, if we have this number in this else block, we will have 13, 133, and 100. These three numbers will be handled by this else block. So we're going to have recursion here that is happening. So let's pretend now we have the first value, which is 1337. So 1337, what shall I do with that? Well, I will say with this number, I cannot do anything myself. So I need to keep dividing until I have only one figure, until I reach this base case, right? Until I can write 1. So I will call again recursively my put number, and I give as an input n divided by 10. By 10, of course, because we are dealing with a base 10 number. Every time I get inside here, I'm gonna call this n divided by 10. Don't worry, we will see with ctutor so we can understand better this point. So I'm gonna have all my recursion. At a certain point, I will reach my case base. Then I'm gonna write, for example, here, I'm gonna write 1, right? Here I have 1. In the case I have this number, I will print that. Then we keep going on with the code which is beneath the recursive call. And here I have 13, 133, and this one. So every function, every clone function has to write its specific last figure, you see? Its specific value which is obtainable with the modulo operation. So I can do here my put char n modulo 10 plus 48. Okay, this is already a piece of code that is partially functional. This is a naive implementation with recursion of this algorithm. I see immediately that I have to my put char, which is always bad when you have to repeat yourself, because you have to try to make your code as dry, don't repeat yourself as possible. Then we are not handling in any way the negative numbers. So this of course is not complete, but let's try to run the code and see the output. So I'm going to compile. Here I have a stupid wording, which is not necessary. So I'm going to compile and launch. Okay, for the first one has worked. For int min, I have a 0. 0 has worked. For 102 has worked. And the last one, which is a negative number, I don't have anything. Okay, so we already have something that is working, but we have to still perform some modification. Okay, so let's handle the negative numbers. So first of all, what do I check? If the number is negative, so if the number is minor than 0. In that case, what do we do? Here I change to an else if. Well, in this case, we have the problem of before, basically. The problem that we add here, right? So I can basically copy this line of code. And here I just do if number is minor than 0 and the number indeed is int min. What do? You just write in the standard output this number. I don't want to deal anymore with that. On the contrary, else, it means that it is minor than 0, but it is not int min. What do? You just invert the value. So you say n is equal to minus n. We are not going to use the choose complement hackish way of doing the thing. You put a minus in the standard output, and then you just call the function again. So put number with n. That this time is a positive value. You see? So you restart. You will restart again. This time, of course, you don't have a negative value, and you just are gonna perform this code here. All right, cool. Let's try to launch again the code, compile and launch. Boom. As you can see, this time the code is working. So here I have int max, int min, 0 for 102, minus 42. That's perfect. So now let's try to optimize the last thing. I told you that we want our code to be dry. So I don't want to repeat my put char. What can we do? I delete dd. And I know that I have many functions. In this case, I have 4 functions that are going to be called. Every function is going to have its value. So here I have 13 in a function, in another 133, and in the last one I have 1337. What shall I do? If I want to write a 3 here, let's pretend we are just the function after the base case. Well, I can call again the function. So I can do another recursion and I can say n modulo 10. You see? So I call the function again. I have 13, for example, in this case. Modulo 10, I'm going to have 3. So I call again the function and we go back to the base case. So the base case thinks that this is this 3 here is the most significant figure, but this is not. This is just another value which is inside the whole integer. Okay. So as you can see, I have 2 recursions, one after the other, and let's try to launch again the code. Launch. Boom. As you can see, it works exactly like before. And we are not writing the same piece of code twice. So this is the recursion. Let's delete the comments so we can see how short this is. So basically is these lines. So the tricky part maybe is only when we have to deal with a negative value, but the actual recursion, if you want, is these 3 lines. Now let's watch on C tutor so we can understand better what is going on. So we start with our recursion. We have initially the int max. Of course, we skip all of this because this is not a negative value. And we start. We check, is this the case base? Is this the case base function which has only one figure? No, it is not. What do? Well, clone yourself. Clone yourself with a value which has the last 7 that has been removed, right, with the division. And we keep going on. So we have all the functions that are calling themselves with a value which is 1 figure less. Every function has 1 figure less in the stack. So we keep going on. As you can see, every time we decrease, we have 21. At the end, we are going to have only 1 figure. You see here, put number when the figure is only the 2, the most significant figure. Then I say, hey, dear function, dear clone, check if you are the case base. Check if you are the special function that has to return. And indeed, you are, because we have here the check, right? Else if n is minor than 10, the rule would be n minor than base, right? If you have an hexadecimal, these would have been 16 and so forth. You put the char. So check the standard output, you see, write the char. So you start with the 2. And then we go back. This function gets deallocated, and then we finish with our pending functions. We start with 21. And now at every pending function that you see here, we are going to call this line. Again, we're going to call the function itself. But this time we pass every time n modulo 10. So you see, at every function, pending function that you see here is going to pass the last figure. You see, that's exactly the behavior that I want. So let's briefly watch what is going on. I call again the function. So if you watch the stack, you will see another function that gets allocated, of course. And then boom, I have 1. I want to print that. And then I'm going to just print in the standard output. Okay, so I have 21. They keep going on. Every clone is going to call again the function with the last figure, you see? So basically, with this little piece of code, every time I'm going to call a case base if you want. My case base thinks every time that is dealing with the most significant figure inside my number, but this is not the case. It's going to print all the figures inside my number, okay? So this is basically what is going on with the recursion. Of course, I suggest to you, as always, to come to these websites and check by yourself the stack discipline, what is going on with this allocation, the allocation of functions, and all the time, what is going on with a call to, with a recursive call, okay? Basically, every time a function is creating a clone of itself, and this allows recursion to work. As you can see, I have in my standard output the value. Here, if I remove this and I just leave this piece of code, I will get a bug that you will see now. I'm going to do if number minor than 0, what do you do? You just invert the number, but nothing happens. You see, when I invert int min, I'm going to stay with int min, because that's the way the choose complement machine work. Again, watch my video if you want to know more, or just search for yourself, choose complement. What does it mean? All right, that's it. We have recursion for this problem. I think it's very crisp, very elegant, and overall not too complicated to understand once you get the gist of it. And then you have iteration, which is this big boy here. We are exploiting an array and we are stocking all the values, all the figures inside this array. All right, that's it for this video. Thank you for watching, my friend. Enjoy.